Hello everyone, welcome back to Calculus 1, and this time we will continue the study in section 2.3 about limit laws, or specifically about the different methods to find out limits. It is just true to find out limit. Eventually we consider direct substitution, which really means given a function and you want to find out the limit as the x approaches to a particular value, you simply replace x with that particular value. Indeed, that is really the way we find out a limit. And if you remember, we may have graphs, we may have tables, but anyway, they are not reliable. The most reliable way to find out the limit, it is really direct substitution. And also we did cover some situation when direct substitution it is not possible. So I did try to save some results from last week. So we talked about briefly when we have a situation where the direct substitution it is not possible, but anyway, numerator, denominator can be factored. And this is the example from last week. Okay, it's not a new one. We observe this limit. It is indeed, if you remember, it is in the indeterminate form, 0 over 0, which really means it could be of anything. But we realize the numerator can be factored and the denominator also can be factored. So indeed, we did figure out this limit very nicely. Turned out to be 3/7. Okay, this is one way to find our limit. When direct substitution it is not possible, we consider factorization, especially, clearly it should be in the situation when numerator and the denominator can be factored. At least one can be factored or both. Okay. And also there's a situation, the other situation we considered from last time, we evaluate a limit when there are radical terms involved. So basically, if there are radical terms, you want to use the approach so-called radical conjugate. And specifically, this is the example from last week too. There's the radical involved, and what I did, multiply the radical expression, with the radical by its conjugate. Because we have this formula, right? Now, can we say this formula? The product of conjugate, radical conjugate pair turns out to be difference of squares. So because of those two perfect squares, there's a chance the radical term will be reduced. The square root notation will vanish. And indeed, it is exactly true. So after using the radical conjugate, we get the limit. In this case, still very nice one, 1/2. Okay. So again, as I'm saying, this section, indeed, it is the most important section about the study of limit, section 2.3, and direct substitution considered for class purpose. This is really the only way you need to consider for the problems on the homework and for problem on the test. You really want to use direct substitution. The graph, the table may give you some idea how the limit would look like, or if there's a limit at all. Okay, we do consider direct substitution. And then the other big issue is when direct substitution it is not possible, there are some tricks or techniques you can consider by doing factoring, and that may make a direct substitution possible by using the conjugate, or it also may make the direct substitution possible. And also there are other situations. Okay, this is the example new for this part of the presentation here. When you have a complex fraction, so this is example 2.19. It's still from the textbook. And you want to give a try. If I plug in value 1 for x directly, indeed, it's going to give the indeterminate form again, 0 over 0. which really means it could be of anything. But one thing I realize here is the numerator has denominators. So this makes the entire thing as a complex fraction. The way we simplify a complex fraction is we multiply the numerator and the denominator by the same common denominator of the numerator and the denominator. I'm not sure if this writing or the way I talk makes sense, but anyway, I think it is just true. Okay, I'm talking about the common denominator for numerator and the denominator together. And then you multiply the numerator and the denominator by the same common denominator. So the common denominator I observed here, there are only two denominators from top and the bottom. That's x plus 1 times 2. So simply I multiply the top by the common denominator. This is just single 2. Or maybe, I think maybe let's just put this number 2 to the middle. Okay. So you may not mistake that as x plus 1 squared those things. Okay. Multiply the numerator and the bottom by the same common denominator. So the fraction, it is still the same, even though it is getting bigger or a lot bigger. But anyway, it is really the same limit as the original one. And certainly you can cancel the extra part for now. But anyway, if you do that, which will make nothing happen, right? So then we look at the numerator part. I multiply numerator out, the terms from the numerator out. So this part, x plus 1 is cancelled, there's single 2. For the second part, minus 1/2 times that entire thing, 2 is cancelled, there's x plus 1 left. Okay, don't rush to do anything for the denominator. Keep the denominator as it is. And also, if you wonder when do we have to do something for the numerator or for the denominator, I would say in general, okay, mathematics. In mathematics, we always want to have simplified answer. And especially when you consider fraction, if the numerator or denominator in the product form, usually you want to keep that product form. It is in a simplified product form, okay? So don't do anything about denominator. Continue to work with the numerator part. I'm seeing this will be 2 minus x plus 1, turns to be 1 minus x. And indeed, I'm writing this as negative parentheses x minus 1 because I suppose you are seeing x minus 1 is a common factor for in the denominator and the numerator. So x minus 1 is cancelled. After cancelling x minus 1, I have the limit in a lot easier fashion, right? And there's no trouble to consider direct substitution. So I just replace x with 1, and I figure out the limit is negative 1/4. And indeed, this is just the true limit. This is the just true limit. The correct limit. Any questions? Well, I guess you cannot ask any questions, but anyway, if you do, send me email or join those online sessions, and we will start from there. And let's take a brief break. Thank you for watching.